This episode of JUXT was originally recorded in May of 2021. Since then, the database formerly known as CRUX has been renamed to XTDB. You can learn more about XTDB at xtdb.com.
In today's podcast, we're going to be talking about the strength of the record. What is a record and why should you care? And now we just want to introduce who's on the call. My name is John Pither. I'm the CEO of JUXT and I spend all day on Zoom.
So I'm Jeremy. I work at JUXT on CRUX. So I am leading the product development efforts. So working with our user base and community to find the requirements and make sure we're building the features that we need to in the right sort of timescales and shape the roadmap.
Hi, I'm Steven. I've been with JUXT for about 5 months now, but I've actually been using CRUX as a consumer for the better part of the past year to build a volunteer project I'm working on, which is a digital library, which makes heavy use of CRUX data modeling and the fact that it's a graph queryable database.
Okay, Malcolm, do you want to give us an intro?
Yeah, I'm Malcolm Sparks. I'm the CTO of JUXT. I'm more of a CRUX user than a core developer. I'm not on the core team, but I'm enjoying programming with CRUX in Clojure, of course, and thinking about the significance of what it does. And I have to say, I know we're not trying to sell CRUX here, but personally, I absolutely love the database and love using it.
Yeah, I think that's right. It's not our intention to sell the database, but we're here on the podcast to understand why we've built it the way we've built it, why we've gone for documents. To help us really understand that, Stephen has gone away and done some thinking. And he came to CRUX of his own accord because of the fact it uses documents. So Stephen has written a blog post about this. I guess the first question might be, what is a record? Because CRUX is a document database. So how do you arrive at the record?
This is actually a good question, and it's a question that we had internally as well when we started using this word. What do we even mean by record? Because people will generally use that term to refer to SQL-based databases and rows and tables. And reasonably, you might even use that term to refer to triple stores. But there's kind of a naming game here where choosing the word record is helpful to differentiate some of the subtle semantics between the kind of document that you would store in CRUX versus the kind of document databases that exist in the wild and have existed for longer than CRUX has been around. So things like MongoDB and possibly Neo4j might be considered document stores, and what you store in them might be considered records. But the record in CRUX, it adheres to a relational model or a relationship model similar to that of Neo4j, so somewhat like a property graph. And it really strongly encourages a relatively flat model. So it's not completely flat. You can certainly store cardinality many values for some of your keys in your record, but it tries to avoid this idea of completely denormalizing all of your data into one gigantic document. So this is part of what we were getting at with the terminology of the record, but there's a bit more history behind it than just that.
So Malcolm, what do you take the record to mean?
When I think of records, I kind of think of the analog equivalents, which are those index cards that you might buy in a stationery shop. And a lot of digital ideas are copied from the analog world. I mean, businesses have been going for almost over 400 years. And over that time, they've created these things. So you might call them tools. Actually, when we started Agile, we had those kind of storyboards capturing user stories on cards. We actually used to go out and buy those physical cards in stationery shops and write on them. And so when I think of a record, I kind of think of starting with a blank piece of, A5 card and begin to start writing notes on, capturing information. And then over a period of time, as you spot patterns, you go from these blank pieces of paper to pieces of paper with boxes and templates on them that become forms. By form, I mean the forms that you fill out when you have to complete a business process or transaction. So yeah, records are very much, for me, still copying what humans have done for centuries and trying to see what parts of that process of information process capture that we want to keep.
Yeah, I guess there's some interesting things though, isn't there? Like the record, it's usually the same shape, like the same sort of size piece of paper, the index cards, and there's the same sort of format to it. And then what you would do with that record is that you would categorize it, you put it into some sort of index. Is that a bit different to the idea of a document that is a bit more easygoing, it's a bit more freeform? You just kind of throw it in, you don't think about the time axes or how it's actually recorded.
I'm sure the document database folks would probably consider that an oversimplification, but I think that that's actually a fair comparison in some respects. Particularly when document databases were new, they seemed to market themselves on this idea that you didn't necessarily need to conform to a particular shape, or to use Malcolm's term, a particular form. You could exploit this schemalessness of the database to get differently shaped pieces of data into the database. And I think that this metaphor or terminology of the record actually pulls back in the other direction and says, well, you have that. You have the option of schemalessness and variability in shape, but actually for any given type of data, you probably want to remain reasonably consistent with every entity that you save, as consistent as possible.
I think in this podcast, it would be good to contrast the different approaches. So we have tables, we have triples, we have the graph database. I suppose taking a step back, the table doesn't have that problem of schemalessness where you don't know what the shape of the data is. You don't have to worry about the data being ingested in different forms. It's a table. It's there. We know what the columns are. We can explore the schema. It's a good place to start to ask the question, what's wrong with tables? Why do we need documents, or why do we need triples? What's wrong with the humble table that served us so well for so many years?
I wrote about this specifically, closing the section on tables by talking about the fact that tables still serve most businesses reasonably well. The fact that their schema is, at least with most SQL databases, reasonably stiff. So you have schema on write, you can validate the data that you're putting into a tabular data store. They're safe. Everybody's reasonably comfortable with them. They have a semi-standard query language of SQL that many developers are comfortable with. The difficulty with tables is that they make the exploratory process extremely painful. So a table sort of assumes that you know what you're doing up front. And so the software development community has come up with all sorts of ways of backing into a solution, which is to say that you take your best guess for version 1 of your software, and along with that best guess, you implement a database refactoring or schema migration system so that you can make the changes going forward that you know that you're going to need. So every software system starts out incorrect. We all sort of know that. And you start heading off into the future trying to manipulate this schema, but you've already baked in something fairly concrete from the beginning with tables. And this poses a real problem in today's world, where often the data you're getting is not coming from a structured, put your name here, put your age here kind of form, the way that Malcolm is describing the sorts of forms that you get on paper that you pick up from the government or from a bank. The kinds of data that you're getting these days are often lumps of semi-structured or totally unstructured data from another system or from a legacy system. And you're actually needing to acknowledge the reality of data crystallization up front, which is that you really want to start with the unstructured data and discover what the structure is over time. And tables really don't provide you with any option there. So people will often come up with as sort of workaround, which is to store unstructured data in a different database and start doing discovery processes, data science on top of that. And then once you have something relatively crystal, then you move ahead and do version 1 of your software in a relational data model. But that is, by its very nature, a workaround.
Well, you see hybrids where people use a kind of JSON blob column within the relational database. So you have columns where everything is organized and crystallized, and you've got like an uncrystallized and unordered place to put your data as well.
I was going to make that point, John. Relational database schemas don't flex, and I think that is perhaps, you're alluding to the JSON blobs in Postgres are a little bit of flexibility, and it's a kind of a little bit of blue tack or duct tape on the whole system. I really echo with what Stephen said. I think most business processes, when we started on the journey of putting things on computers and putting things in the digital world, most of the business processes had already stabilized. They'd already been mature over centuries, at least decades. And so the domains were well established, the processes were well established, and so therefore there wasn't much exploratory work to do. You would just copy a process. You would take a business ledger, perhaps a financial ledger, and you would copy the columns, and that would be your schema. And so much of it, the work had been done for you. Now, because all of that kind of low-hanging fruit has been picked, we've been using computers for decades now. So we are now inventing new business processes using computers. And that's the problem, because as Stephen said, that schema development is not a good, agile, flexible, quick tool.
That's a great point. I think in the answer to do we want to go for records or documents or triples or tables, of course it's going to be, well, it depends. It comes down to the context. And I think what you're saying, Malcolm, really rings true in that the early systems, where we know what the schemas are, the systems are, dare I say, simpler. They're more well-defined, like the first steps of computerization. So we can work with these rigid schemas. But now we're having to build things like data lakes and data meshes and data's flowing around from different sources. It's just a lot harder, as Stephen would say, to crystallize that data shape up front.
I would also like to make another point about you sort of judge a tree by its fruits, and you can observe what happens to projects that do relational modeling. And there's lots of observations you could make. But one observation I would point to is that I've not seen many database schemas scale beyond a couple of hundred tables. I mean, you may have other experiences, but I think the problem of database scalability is that there are just too many things that happen when you have a large schema, and people start wrapping them in view objects. But doing small refactorings on a big database then has a ripple effect. For example, in SQL, you've got lots of tight couplings between all of the SQL statements in your application and the names of your columns in the database and tables. And so things are fairly rigid and tightly coupled. Another thing that you observe is integrity constraints start getting in the way. And so I saw a beautiful observation a few years ago that showed almost like a half-life decay, those like half-life diagrams of a decay of a uranium atom, and just saying that non-nil integrity constraints of columns in a database, you can almost work out the age of a database just by counting how many columns have had their not null integrity constraint relaxed, because somebody's had to say, date of birth, we don't know the date of birth for this record, so we're going to have to make that relax that constraint so that we insert this record. And so it's just interesting that in the experience that we've had of building big database systems, the relational model is absolutely beautiful in the small, but it doesn't scale up to the large.
Yeah, that's great. Stephen, you make the point of active records and object mapping, which is where you take this kind of anti-pattern of crystallizing the data up front, but you take it all the way through the code base. You start building objects out of these schemas and types, and it really propagates. So it gets harder. I'd like to ask about triples, which feels the complete other direction. Malcolm, you're a bit of an RDF nut. I think I first encountered you giving a talk on RDF about how you were applying it at a bank. Could you give us a bit of an overview, or could you sort of help to tie this back? Because what we're trying to do is consider what's the one that we want to use, which do we think is best? And obviously context will play a big part, but it's useful to get them on the table. So do you want to give us a quick tour of the triple?
Yeah, I'll give you a quick explanation of what a triple is. If you take this statement, the cat sat on a mat, that is a fact about a cat sitting on a mat. And a triple is a statement like that. The cat in this case is the subject. The sitting on is actually the relationship that the cat has with the mat, which we call the property or the predicate. And then the mat is the object or the value. And so the triples are really a kind of an observation that everything reduces down to those kind of statements. Everything is reducible. So for example, a table, each row in a database table is just really a collection of triples. You can say that John is 40 years old. You might store the 40 in a database record, but can be extracted as just a set of triples. It's a little bit like the way that computer graphics, everything can be reduced to triangles. If you know how to paint a triangle to a screen, then you can paint any shape to a screen because you can divide any shape into triangles.
Feels immensely powerful. Stephen, you obviously thought about this in your blog post and contrasted it to documents and tables. What's your view on it? Because on the one hand, it seems just amazingly powerful. It's like getting back to atoms, and then you have to reconstruct them to make sense out of them. What's your take on triples?
I actually really like the comparison to triangles and computer graphics. I think that there's probably something to be said about the computer science metaphysics there of reducing something to a shape with three parts, because it's sort of understood in, I'm not an expert, but in this field of knowledge management that you can't go any smaller than that. you need these three pieces to construct a fact. And likewise with triangles, you can't go any smaller than those three vertices. I did actually attempt to use a triple store for a large piece of experimentation software. So experiments feeding data into a data science platform. This was maybe 6 years ago or so. And I think everybody has this initial attraction with triples, or possibly in the linked data space, RDF, because triples can be either RDF triples, which have a predicate in the middle, or they can be simple EAV triples, which simply say, oh, okay, this property of this entity has this value. And I actually liken it to Indic languages in some ways. So ancient Indic languages sort of had these two levels, one being the Sanskrits that I think that people are very familiar with. So all the epic stories and many religious texts are written in the Sanskrits by the educated class. And then there are a number of Prakrits, which are the lower language of the people. And Prakrits were generally not written down, and they were spoken by everybody. Sanskrit actually means purified, sort of sophisticated, and Prakrit actually means natural. And so I think that triples can be thought of in these terms, that triples are a sort of Sanskrit. They're a sort of purified, very high-minded, very sophisticated construct. And there is a certain purity to them that is very, very appealing initially. You think, oh, okay, I could do anything with this. It's so powerful. And it has the same sort of appeal, to me at least, that Lisp did initially. I was very attracted to Lisp long before I was ever a Clojure programmer. And you read books like Practical Common Lisp or something goofier like Let over Lambda, and you think, oh, Lisp is so amazing. I really wish I could program in this all the time. When you start working with Lisp, it has this sort of beauty to it, but it's also somewhat comfortable to program in a Lisp, particularly a practical Lisp like Clojure. And I think that my experience with triples was unlike that. We started working with triples and we were constantly fighting against the purity of the triple and trying to take reasonably natural data and transform it into this purity that triples can express. Ultimately, we ended up pulling out the triple store and using Postgres because it was easier for us to understand and it was more performant. So I think even on the Crux team, this has been a debate, and I think will continue to be an ongoing debate as to whether or not, well, triples are pure, shouldn't we go that route? But ultimately, particularly EAV triples, they're just a component of a record. So any record in a database like Crux, it doesn't need to be Crux, which stores essentially atomic entities or atomic documents or records, each attribute of that document can be seen as representing an EAV triple. In Crux in particular, you query using Datalog and you query using EAV triples just as you would a triple store. For me, at least as a user, that's the best of both worlds. I want to be able to think in triples, but I don't necessarily want my database to encode triples because that sort of adherence to that level of purity is a little bit too much. It's almost like building a graphics system and being forced to work in triangles all the time instead of being able to pull yourself up to a higher level of abstraction and say, well, no, actually over here, I just want to be able to talk about spheres. I don't really want to assemble 1,000 triangles.
I agree exactly with that. Relationships are everywhere, and a lot of them we know about. A lot of relationships we discover, and so many things that are related to each other in weird and wonderful ways. And if you start out with a table, you make it expensive to capture relationships. So every time you want to relate one thing to another, you have to relate the whole class of thing to another class of thing. There are relationships between sets of things and classes of things, but sometimes you just find that individuals have relationships and sometimes separate relationships to other individuals, to other things. Nature is just full of this. And if you're trying to create a new application and you're exploring, as we kind of touched upon before, if you don't know the domain inside out or it hasn't matured and you're trying to discover something about the world, you need to make it really, really cheap to capture relationships when you find them, because those relationships can sometimes end up being super important. But I agree with you too that just boiling everything down to relationships, you lose a lot. In fact, I talked about the statement, the cat sat on the mat, but there are other things that you might want to know about that statement. There's lots of context around statements and relationships. In Crux, we like to capture the business time or the transaction time, or when the actual record, when the card was actually put into the box or, made official or stamped. And so the context that we can add to a record, I think, is very important. We can take the relationships, we can add that to a record, but we can then also add the metadata, the context to it as well.
Yeah, that's a great answer. I guess the record, it's not as pure, like Stephen says, as the triple. So you might suffer from some duplication. You have to deal with these broader objects, these records. So they carry with them the whole record, the whole document. But as you say, that gives you some capability then to apply more context around it, which might be a bit harder to do, at the level of the fundamental triple, that fundamental triangle. Is there a case where you might choose the triple? So I think we're coming at it from perhaps as maybe a bit of a bias in our recent experience. We're in this more of a data lakey type space, and data's flying around the enterprise, and it's a bit unstructured, and it's kind of easier to whack it into a sort of record store, a document store, and then to make sense of it, to explore it afterwards with powerful query capability like Datalog. But is there an example where the triple makes inherent sense? Like, it's a good domain for it. It's a good place to use triples.
I think to some extent, you can actually sort of lean on yesterday's weather when it comes to triple stores. If you look at where triple stores, and in particular RDF stores, have been successful over the past decade, the domains are varied, but the domains where you see them repeatedly used, especially RDF stores, is the space of long-standing data, particularly for the public. So government data sets and library data sets, world governments, libraries of Congress, any of these data sets that I've seen, they tend to be recorded as RDF and then exposed as RDF. So one of the beautiful things about RDF is that because it makes heavy use of URLs and the idea of a resource locator that other people can understand outside of your system. So I haven't identified this thing with an integer 123. I've identified it with a URL. A system completely outside of my office, outside of my government, outside of my country can pick that up and understand it. That really makes a lot of sense. So certainly in the linked data space, in these open data set spaces, triples still work very well. And I think that there's a sort of flip side of that, which is that those organizations tend to have a really clearly defined set of goals. So we want to take all the inventory of our Library of Congress and we want to digitize the inventory and expose it to the public so that anyone can query this data set. That's well understood. And even though it might take you 4 or 5 years to actually build up that RDF system, it's doable. And a government with a Library of Congress probably has the budget to build a system like that. So even if some of the data constructs feel unnatural at first, they'll have the time and they'll have the runway to do it properly.
Yeah, I was at a conference today called The Data and the Future of Financial Services. Very, very interesting. There's a very, very good talk on measuring environmental emissions and how you achieve governance where you can monitor companies and ensure that their emissions are, that their reporting are accurate and so on. And then being able to aggregate those emissions to find out, for example, what the emission levels are for a country. Now, if you think about the challenge of adding up emissions, you're suddenly struck with this problem that if everybody's reporting their CSV data set and nobody really knows what each of the numbers mean and what the columns mean, they might make sense locally in that company. You might know that column G happens to be the level of emissions in micrograms. The great thing I think that came out of the work of the semantic web was the establishment of vocabularies and ontologies. Stephen talks about these URLs, which were globally unique statements to say, this is the URL you use for a property, which means that this is the emission of carbon dioxide into the atmosphere and the units as well. And so the ability to standardize and aggregate and interoperate data sets would have been far improved were the ontologies more established. And I think they were definitely heading in the right direction. One of my observations at this conference was that really, the world is a much poorer place because these agreements of ontologies haven't become more established.
So this is actually something I've heard before, which is that the problem with RDF has been the tooling more than anything. I think agreeing the act of creating these schemas and ontologies and vocabularies is difficult, hard work, but the tooling to do that and then to build applications which manifest those schemas in a way that people can then use has never really aligned with the scale at which people have tried to do it. When you talk about triples, most people working with triples aren't using a triple database as sort of the master store. They have these n triple files, for instance, on an FTP server. That's the canonical place that data is stored. But at least it is self-describing. And I think the big difference with databases, or at least certainly like a relational database to bring it back to the table structure, is that the schema is defined up front, and triples is also similar. The schema has to be defined up front in order for you to sort of encode those things as triples. The problem with that is that the ability to arrive at consensus then falls on the tooling rather than the place that the data is stored. So in order for sort of you to have a shared consensus building exercise with triples, the ability to evolve those vocabularies within the store itself needs to exist. As far as I'm aware, there isn't like an integrated story there. Whereas the records, we're saying, well, we're not going to standardize in the schema up front. The records are, maybe that we'll say, this one's using JSON schema, or this one's using, some Avro or something like that. But these things can coexist in the same data store.
Let me ask a question then. So we're building this product called Crux, which is a database, and it uses documents. It uses records, to use the correct terminology. But a question that I have to ask is, what's the downside of that, right? So we're going down this data lakey route, and we're ingesting these schemaless documents, and the form of them can change. And yes, we've got this graph query capability to query across them at a later date and at different points in time. But is there a concern that if too much schemaless data gets in there, wouldn't it just get beyond a sort of event horizon of messiness, where it just gets too difficult to query across it because the shapes of data are too chaotic? There's so much data that's been accumulated, it gets difficult to explore your way through it to get the insights that you would want to.
That's a perfectly valid question, right? So it really depends what sort of system you're building. And I think that it's interesting that Jeremy calls out that a lot of these systems that expose triple data are really just storing files on disk. They're not storing anything in a database for any meaningful definition of the word. There's sort of a spectrum of different kinds of systems that a person might build with the different kinds of data stores that are available, that are out there. So one might be that you're ingesting a large amount of loosely structured data or unstructured data, as you can with Crux. Another might be that you largely know your schema up front. So just because schemas tend to crystallize over time doesn't necessarily mean that you don't have a clear idea of the 90% case of what your schema is going to be from the very beginning. And the digital library that I'm working on is probably an instance of that. So even though we're not ingesting a lot of unstructured data per se, we actually find ourselves bringing in data that is much more like the shape of data you might put in a regular relational database. So define your tables, put your data in here. In a few months, maybe we need to add a column to capture some new data. Okay, we'll do that. And that's perfectly all right in Crux. But the fear that you've pointed to is precisely a fear that we've needed to deal with on that project, which is, well, what if we accidentally record some data we didn't intend to? Because we actually have a relatively strict schema, even if Crux itself isn't enforcing schema on write. So our way around this is essentially to add a layer before Crux, which says, oh, okay, I'm checking your schema for you based on something that someone has defined, and then I'll put this data in Crux for you. That works reasonably well, and it still leaves the option to circumvent that layer and say, oh, okay, I just want to ingest, I have some JSON or some documents that I want to add to the database. I can still do that in a fairly ad hoc manner. I wouldn't necessarily do that with that system, but the flexibility is there. I think that there's probably still discovery to do in this space. I think that the document databases of 10 years ago, they ended up reinventing the wheel, and they kind of only came up with half a wheel. They did this huge denormalization thing, and then over time realized that, well, that doesn't actually work. I need some normalization of my data, which requires that I have a join. And the helpful starting place for a database like Crux is that we have a reasonably standard query language of Datalog and also SQL, but I mean, that's kind of an aside, that you can build on top of to say, okay, there's already been a bunch of work in the field of computer science around Datalog. A lot of thinking has already gone into this. And Jeremy's done some interesting work around very graph-shaped data. So where your records or your documents are really referring to one another quite a lot, and you're exploring the graph as much as you are pulling individual documents out of the database. That sort of thing really benefits from a query language like Datalog. But I think that the question of this landscape of the different types of software that you might build on top of a database, it still has some unanswered questions. So is the data that you're ingesting in your database asynchronous? Like, do you care that you know that you've recorded it when you fire off a transaction, or do you send it off and you trust that the database will take care of it for you? What kind of throughput do you have going through the database? Obviously, if you have a bunch of triples stored in some file share somewhere, throughput is very, very low. Do you care about explorability and discoverability in the data, or do you think of it as being a reasonably consistent thing? And how much data do you have? Like, do you have millions or billions of entities in your database? I mean, all these different shapes of different kinds of systems, they're amenable to different solutions. So there are times that, yes, you definitely just want Postgres. You already know all your shapes. This is going to be simpler on a relational database. You're not doing graph explorations. You're not doing anything with unstructured data. There's also times when you would probably want to stick to triples. I think that Crux is learning what it is in time to some degree, but it's also captured a lot of learning over the past 10, 20, 30 years of database research to say, oh, okay, there were actually a bunch of really great ideas. And some of them from 1985, some of them from the mid 90s were around bitemporality and querying data over time, which we haven't actually really spoken about yet, the immutable nature of data or the bitemporal nature of the data in Crux. But taking all of those lessons and sort of saying, oh, okay, if we start from scratch, if we start over, what are the lessons that we can apply in coming up with sort of a next generation kind of database? And I feel that Crux makes a reasonable play at most of those things. But you're right, there are probably spaces for additional layers on top of Crux for things like schema on write, for example.
Can I put you on the spot here, the people on the call? What do you think of this idea that if you want consistency of the shapes of your data, what do you think about the idea in a bitemporal sense, using this valid time that's fungible to mutate the data to get it into a consistent shape? And you can do that with valid time. The database is immutable, below that with transaction time. But the idea of sort of updating your data to get it into a consistent shape, you might do it at set intervals. You might do it for a particular reason over a course of time. But do you think that's a valid strategy, or would you tend to keep unstructured and explore your way through it? I guess it's a trade-off, right?
Yeah, I think humans are messy and you can't change that. You can't change it by training or teaching. You just have to accept the fact that humans are messy. But, some of my code, believe it or not, is a bit messy. But I keep it in a Git repository, which developers all know what that is. And it means that I can go and clean up the mess and I can make changes to it. It's always very nice when you release software to know, even if you've released messy software, to be able to go back to that version of messy software and you see it's still in a mess because that's kind of the state it was in when you built it. That's such a fundamentally important thing for us developers. I don't think any developer I know would ever go back to where we just had messy file systems which we would clean up ad hoc without any audit trail or history of what had been cleaned up. And I think also when you do make changes to data, like in a data lake, if you've got lots of unstructured data and then you go and clean it up, it's very, very important to be able to trace back the clean data to where it came from, the provenance, how it got there, how it derived. Going back to your kind of original question, is Crux the perfect database? I don't think so. It does point to having better building blocks for building such a thing. I don't think there would be one universal perfect database for all domains, but I think you do need better building materials. So Crux does have that nice property that it shares with Git. It is kind of immutable. It has that kind of history, which I think is a key feature. And another one, I think it builds on a surprise that a lot of us people, Java developers who discovered Clojure, was that we were really quite skeptical about, can you do so much with just a humble map? And, it turns out you can do amazing things. If the only tool that you have is a map, and often you do need to bring in a little bit of type system or a schema, or you need to tidy up in certain cases. But it's still incredible what you can do with maps just as a building material. So I think that Crux has got some nice observations, as you say, baked into it that give you those building blocks to create something that is really much, much better fit for your domain.
Yeah, it's quite a mind-blowing moment when you think you can just work with a map, but then a schema can also be a map. And then the schema of that schema can be a map, and you can version control them differently. Your head can start to explode, but in a good way. There's lots of possibilities.
Well, on that rather starry-eyed thought, I think we should wrap up this episode by briefly recapping that maps are just an implementation of records, and that this metaphor of a record is nothing fundamentally new, but it's a fitting way to convey the idea of a graph of immutable facts on a timeline that is tolerant to ever-changing requirements. So whilst Crux may have transformed into XTDB, this underlying data model is definitely here to stay. So this concludes the JUXT episode. Thank you to our hosts and guests, John, Malcolm, Stephen and Jeremy, and also to the various people who provided input to Stephen's written article. You'll find this along with plenty of other long-form content on xtdb.com, including articles on adjacent topics like blockchain and bitemporality. Please follow us on Twitter if you haven't already at xtdb_com and share your thoughts. Thank you for listening, and make sure to subscribe to receive notifications on our new episodes. Until next time.